So children, in the last video we have discussed about one of the technique of searching that we use in the arrays. So over there, what was the strategy? That strategy was that we will be comparing all the elements of the array starting from 0, and when we will find the number at the particular index number, so we will be returning that index number. Okay, now the next kind of search technique that we have is the binary search. Okay, so binary search works on a strategy that is called as the divide and conquer policy. The thing is called as divide and conquer policy. So what is a strategy or policy, or you can say it is as a strategy, or you can say it as a strategy. So what happens in this, like if you have an array, like this, so in this case what will be happening in the binary search, that whatever number you are searching for, you will first compare it with the middlemost element. You will first compare it with the middlemost element of the array. Okay, and after comparing it with the middlemost element, you will be able to find whether the number is on the left or on the right of the middlemost number. And how you can find this? Because in case of binary search technique, you need a sorted array. Sorted means what? Like 1, 2, 3, 4, 5, 6, 7, 8. Like this elements are there. Like means they are having a particular pattern. Like if it is 1, 2, 3, 4, 5, 6, 7, 8, so they are in the ascending order, right? So this kind of arrays are needed for the binary search. So when you will compare that, suppose we have to find the number that is 6. So in this case, what will happen? That first you will be comparing that number with the middlemost element. So middlemost element is 4, not 6. So this condition will be what? Not true this time. So what happens in this case, that if we are not found that number on the middlemost element, and now we know that if the number is greater than this middlemost element, so it will be found on the right of this middlemost element. Otherwise, if the number is smaller than this number, the middlemost number, so it will be found on the left. So according to that, we will be searching the element in this array. Now, coming over to the program for the binary search. In the program for binary search, first we are declaring the class, then main function. And in that main function, we have first taken an array by the name array, IAD array, and then like you can just change the name because I have taken the same name, and that is a kind of keyword for you, so better to skip that name. Okay, so I have taken the name over here as array, ARR. Okay, so in ARR we have these elements 10, 15, 20, 25, 40, 45, 63, 70, 77 and 90. So you can see that the elements are in particular order. So in this particular order elements, so what we need to find? We need to find an element that is equal to 77. So in this case, what we need to do, that we need to first write down the criteria or the strategy through which we can write down the code for the binary search. So in case of binary search, what we have done over here, that we have inputted, or we have taken the input as one input of the array over here, and then we have taken the lower bound, the upper bound, and the key of the element. The data type over here is missing, so I will just correct this. So this is INT key. Okay, so this key we have to search. Now the thing I have told you over here, that first you will be finding the position. So position is equal to lower bound plus upper bound upon 2. So in this case what will happen, that now you will be just taking the lower bound and upper bound. So lower bound over here, how you will find the lower bound? The lowest index that you have is the lower bound, and the upper index that you have is your upper bound. So this will be index is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So 0 plus 9 upon 2, that will be equal to how much? It will not be 4.5 because the data type we have taken over here is integer. So in case of integer, you will take the value as on the fourth index, okay? It will not be 4.5, you will be considering 4. Sorry. So on the fourth index you have the element 40 and you are searching for an element that is 77. So you have to compare, you have just compared the 77 with 40 and the value of key is greater than the middlemost element. So you will be searching on the right half of the array. The right half of the array you will be searching for. Now this while condition is written, which is will be checking for array position not equal to key and lower bound is not less than, and lower bound is less than upper bound. And then what will happen, until the array position is greater than key, the position of the ARR array position is greater than key, what you will be doing, that you will be reducing the upper bound. But in case the other way condition is there, that means the position is less than the key, so in that case you will be just increasing the lower bound. And finally the position will be found again for the lower bound and then it will be compared. So in this way you will be finding the, or you will be searching for the element if you are searching into the binary search technique. So that's it in this video then.